Welcome to our second sample solution from the exercise group 9.1. And the one I want to focus on this time is 9.10. Our first set member is there is an x, Lxx. Our second set member is it's not the case that there is an x and there is a y such that Lxy and Lyx. Now, when we evaluate our tree here, what we notice is that we have an existentially quantified sentence and we have a negated existential quantifier here. It's a good idea always to deal with the negated quantifiers first. So we're going to check that one off and write down line 3, which is going to be for all x, it's not the case that there is a y, Lxy and Lyx. And that's going to come from line 2 by negated existential decomposition. Now we might be tempted here to deal with this negation here by using a negated existential quantifier rule. But strictly speaking, we can't do that because this whole sentence isn't a sentence that begins with a tilde and then a quantifier. It begins with a quantifier. So this is a universally quantified sentence, and so the only rule that applies to it is the universal quantifier decomposition rule. So we can't deal with this negation at this stage. So what we really have is a universally quantified sentence and an existentially quantified sentence. So we have to deal with the existentially quantified sentence first if we want to save ourselves a few steps. So let's do that. Now, since there are no constants appearing on the branch, I can instantiate that first sentence to A, and the way I would do that is just by replacing x with A wherever an x appears. So I'm going to write down LAA. That comes from 1 by existential decomposition. Because I have a universally quantified sentence here on line 3, I can instantiate it to A as well. And when I do that, what I get is the following. It's not the case that there is a y, Lay and Lya. And that comes from 3 by universal decomposition. Now notice what I did here in instantiating to A. All I did was get rid of the quantifier, right, of the universal quantifier, and then wherever I see an x, I substitute in an A. And the order here is absolutely crucial. We have to put it where the x goes. That's why it's Lay and Lya. Okay, now when I evaluate my tree, what I see is that I have a literal, as the book calls them, and I have the negation of an existentially quantified sentence. So now I can deal with this negated existential quantifier by writing for all y, it is not the case that Lay and Lya. And that comes from 5 by negated existential decomposition, which I can then check off. Now when I look at my tree, I have 2 universally quantified sentences and a literal. Now what's nice about the sentence on line 6 is that if I instantiate it to A, it looks like I can close my tree, which indeed I can. Because now to instantiate this one to A, all I do is wherever I see y, I substitute in A. I drop the quantifier and substitute in A wherever I see the y. So that gives me, it's not the case that Laa and Laa. That comes from 6 by universal decomposition. And now I just use my negated conjunction rule to branch this out to get not Laa over here, not Laa over there, from 7 by negated conjunction, and both of these branches close. Because on this branch I have not Laa and Laa, and on this branch I have not Laa and Laa.